galactic energy provider, cosmic fixed point, and the very heart of our planetary system, the Sun is undoubtedly one of the most extraordinary celestial bodies in the universe. Imagine a vast powerhouse that not only dictates the rhythm of life on Earth but also shapes the dynamics of the entire solar system. Without the Sun, life as we know it wouldn't exist, not even our Earth in its familiar form. It's easy to take for granted the glowing disk we see in the sky every day, but beneath its dazzling brilliance lies an intricate and awe-inspiring cosmic entity. What we see as a golden orb in the sky is a far cry from the intricate details and jaw-dropping phenomena revealed through high-resolution images captured by modern telescopes and space probes. Today, we invite you to join us on an incredible journey to explore the most breathtaking images of the Sun ever captured. Through these visuals, we'll uncover secrets of the Sun's surface, delve into its core processes, and witness phenomena that seem almost otherworldly. But before we dive in, if you're fascinated by the cosmos and want to see more captivating videos about outer space and space exploration, subscribe to Curious Explorers. Don't forget to give us a thumbs up if you enjoy this content, and stay until the end for links to even more exciting videos. The Sun, our solar system's engine, stands as a colossal force of nature, dominating its surroundings with sheer size and power. At a staggering diameter of approximately 870,000 miles, it dwarfs all other celestial bodies in our planetary system. Yet, in the vast cosmos, the Sun is surprisingly average, a humble dwarf star among the countless giants that populate the galaxy. What makes dwarf stars like our Sun remarkable is their ability to generate immense energy through nuclear fusion, where hydrogen atoms merge into helium under extreme pressure and heat. From Earth, the Sun appears as a bright yellow orb, a result of our atmosphere scattering its light. Viewed from space, however, the Sun shines in a pure, brilliant white, a mesmerizing sight unaltered by atmospheric effects. Its energy reaches us across 93 million miles, a distance that seems incomprehensible but is just right for life to flourish on our planet. This delicate balance between distance and energy output creates the perfect conditions for water to remain liquid and ecosystems to thrive. Throughout history, humanity has revered the Sun, attributing its life-giving properties to divine or supernatural forces. Ancient Egyptians worshipped it as Ra, the powerful sun god, while other civilizations built monuments aligned with its movements, from Stonehenge to Mayan pyramids. The Sun's role in shaping our calendars, dividing time into days and years, has made it central to human culture and understanding of the cosmos. Despite being 110 times larger in diameter than Earth and possessing 330,000 times its mass, the Sun's lifespan is finite. Scientists estimate that our Sun is around 4.6 billion years old, and it has about 5 to 7 billion years of life left. When its hydrogen fuel is eventually depleted, the Sun will expand into a red giant, swallowing nearby planets, including Earth. This phase, though destructive, is part of the natural life cycle of stars. Unlike larger stars, our Sun won't end its life in a spectacular supernova. Instead, it will shed its outer layers, leaving behind a dense core known as a white dwarf surrounded by a glowing planetary nebula. Even before this dramatic transformation, changes in the Sun's output will likely render Earth uninhabitable within 500 million years, a sobering reminder of our planet's fragility. At its core, the Sun is a fiery cocktail of hydrogen and helium, with trace amounts of other elements like carbon. This chemical composition fuels the fusion reactions that generate its immense energy. The Sun's photosphere, the layer where most of its light originates, reaches temperatures of about 9,900 degrees Fahrenheit. However, deep within its core, the temperature soars to a staggering 59 million degrees F, a crucible of creation where atoms are fused. Observing the Sun up close reveals a dynamic, ever-changing surface. Dark patches known as sunspots dot its photosphere. These cooler regions, while still incredibly hot, appear darker due to their lower light emission. Sunspots are windows into the Sun's magnetic activity, often heralding solar storms and flares that can impact Earth's space weather. Beyond the Sun's visible surface lies its corona, a shimmering halo visible only during solar eclipses. This outermost layer, composed of charged particles, dust, and gases, defies logic by being hotter than the surface beneath it. The corona's temperatures can reach millions of degrees, a phenomenon still not fully understood by scientists. From the corona emerges the solar wind, a stream of charged particles that travels at supersonic speeds, reaching between 200 and 500 miles per second. These winds influence the entire solar system, shaping planetary magnetospheres and creating stunning auroras on Earth. However, they also pose challenges for astronauts and satellites, making their study vital for future space exploration. In February 2020, the European Space Agency, in collaboration with NASA, launched the Solar Orbiter to unravel the Sun's mysteries. Equipped with cutting-edge instruments, the spacecraft aims to study the Sun's poles, magnetic fields, and solar winds in unprecedented detail. By June 2020, it had already approached the Sun to within 48 million miles, capturing groundbreaking images. Among its discoveries were solar campfires, tiny flares millions of times smaller than typical solar flares. These structures, previously unknown, may hold clues to how the Sun's corona remains so inexplicably hot. Scientists suspect they are nanoflares, tiny bursts of energy that collectively heat the corona. The sheer number and distribution of these campfires astonished researchers, opening new avenues of study. High-resolution images also revealed the Sun's granulated surface, a mesmerizing pattern resembling golden grains of sand. These granules are the tops of convection cells where hot plasma rises and cooler plasma sinks, creating a dynamic and ever-changing texture. Each discovery brings us closer to understanding the Sun's complex behavior and its influence on our solar system. From solar flares that disrupt communications on Earth to the magnetic fields that shape its activity, the Sun remains a source of endless fascination. As we continue to explore the Sun through missions like the Solar Orbiter, we gain not only knowledge but also a deeper appreciation for the star that sustains life on Earth. What do you think about these awe-inspiring images and the mysteries of the Sun? Let us know in the comments below. If you enjoyed this journey, don't forget to subscribe to Curious Explorers and give us a thumbs up. Stay tuned for more cosmic adventures, and until next time, take care.